Under the frozen morning sky of February 1943, the thunder of engines echoed over the assembly lines of Willow Run, Michigan. Steam rose from the factory roof like a battlefield smokescreen. Inside, tens of thousands of workers, men and women in coveralls, their faces streaked with oil and exhaustion, moved with mechanical precision. Sparks danced from welders' torches, rivet guns cracked like distant gunfire, and in the middle of that industrial storm, another B-24 Liberator bomber took shape. It would roll off the line before the next hour struck. America was now building warplanes faster than the Axis could shoot them down. U.S. War Production Board, Feb 1943. Across the Atlantic, in the damp tunnels beneath Essen, Germany, the mood was very different. The Luftwaffe was bleeding aircraft faster than they could be replaced. In the Ruhr's steelworks, the furnaces burned day and night. But coal trains arrived late, power failed often, and bombers overhead forced workers into shelters more than onto assembly floors. Hermann Göring's promise, that the Reich could outbuild any enemy, was becoming a bitter joke whispered in factory corridors. Bundesarchiv Worker Diary, March 1943, yet at this same moment, in a patch of Michigan farmland that once grew corn, Ford Motor Company had built something the world had never seen, the largest factory on Earth, designed not for cars but for bombers. Henry Ford's engineers, men like Charles Sorensen, the quiet genius behind Ford's mass production line, had reimagined the art of making war machines. Instead of hand-built planes that took weeks, assembly moved on a continuous line nearly a mile long. Aluminum frames glided past stations where thousands of hands, synchronized to seconds, transformed raw metal into flight. Willow Run Production Records, 1943. The Luftwaffe's intelligence reports struggled to comprehend what the Americans had done. Impossible figures, one officer scrawled in disbelief after intercepting shipping manifests showing hundreds of aircraft leaving U.S. ports each month. German Air Ministry intercept, April 1943. They didn't understand that this was not traditional manufacturing, it was industrial warfare at a scale never before imagined. The United States had turned its factories into arsenals of democracy, and each rivet gun, each conveyor belt, was a weapon. The contrast between systems was total. In Germany, master craftsmen still assembled aircraft largely by hand, relying on skilled labor and meticulous detail. Production of the Messerschmitt Bf 109, their workhorse fighter, crawled at a rate of perhaps 20 per day in early 1943. In the U.S. by that same year, 15,000 factories fed into a vast network of subcontractors, aluminum smelters in Pittsburgh, engine plants in Ohio, rubber from Louisiana, propellers from Hamilton Standard in Connecticut. Everything moved in rhythm, coordinated through telegraph lines, logistics maps, and mathematical scheduling that seemed almost supernatural to German planners. U.S. Army Air Force's Logistics Branch Report, 1944. The skies over Europe reflected this imbalance. By mid-1943, Allied bomber streams, 100 strong, stretched from the English coast to the Ruhr Valley, their silver fuselages gleaming like a metallic river in the dawn light. German fighters scrambled, engines screaming, ammunition belts clattering into place, but there were never enough planes, never enough pilots, and never enough fuel. For every bomber the Reich destroyed, America replaced 5. RAF Bomber Command Operational Summary, July 1943. Inside the German factories, the pressure turned desperate. Forced laborers from occupied Europe worked under armed guard. Ersatz materials replaced aluminum. Machine tools ran until they broke. Even then, production goals from Berlin kept rising, disconnected from reality. Albert Speer, the new armaments minister, pushed through reforms. But Allied bombing raids tore apart supply chains faster than he could rebuild them. The American system, immune to enemy bombs and fueled by oceans of resources, grew only stronger. Speer Memoir, 1946. Meanwhile, in Detroit and Buffalo, engineers worked night and day on innovations that would compress hours of labor into minutes. Fixtures and jigs allowed untrained workers to align aircraft parts perfectly. Prefabricated modules, wings, fuselage sections, tail assemblies, arrived ready to snap together. Factories became orchestras, their rhythm measured not in music but in revolutions per minute. And the conductor was the clock, 1 plane per hour. Ford Motor Company Technical Division notes, 1943. The psychological effect was staggering. For young American soldiers watching bombers fill the sky, it was proof their nation's promise was real. For German soldiers below, it felt like facing an industrial tide that could never be stopped. "Every day there are more," one Wehrmacht observer wrote after seeing an unending formation pass overhead. "It is as if America builds them faster than we can shoot them." Wehrmacht observation log, Normandy Sector, 1944. Back in the United States, this production miracle wasn't just about machines, it was about people. Housewives became riveters, farmers became mechanics. African-American workers, long excluded from skilled labor, entered factories under President Roosevelt's Fair Employment Order. Each shift blurred the lines between civilian and soldier. They were fighting the war with wrenches instead of rifles. U.S. Office of War Information, 1943. Still, the process was not without failure. Early B-24 models from Willow Run were plagued by defects: misaligned wings, leaking fuel tanks, faulty electrical wiring. But Ford's engineers refused defeat. Within months, they refined assembly sequencing, introduced modular inspections, and installed precision jigs that reduced error rates by 80%. Quality climbed even as speed accelerated. Engineering Review Board, Willow Run, 1943. By late 1943, the statistics defied belief. Over 650,000 aircraft workers across America produced 85,000 planes in a single year. A new B-17 Flying Fortress rolled out every 63 minutes, a P-51 Mustang every 27. Entire airfields filled faster than the Luftwaffe could destroy them. U.S. Army Air Force's Statistical Digest, to 1944. Even Eisenhower marveled. "The American production line is our most powerful weapon." Eisenhower Diary. DEC 1943. In Berlin. Planners convened crisis meetings, poring over reconnaissance photos of Detroit and Los Angeles. Some believed the images were fakes. "No nation can build such numbers," one engineer muttered. Yet by 1944, even Speer admitted the truth. Germany had lost the industrial war before losing on the battlefield. Speer interrogation transcript, May 1945. Still, the secret behind America's astonishing pace wasn't merely manpower or machinery. Something else was driving it. A hidden advantage that Germany's engineers failed to grasp. An innovation buried in the humming heart of every assembly line. It wasn't about steel or oil. It was about how thousands of separate factories, suppliers and workers acted as one organism, connected, synchronized and self-correcting. That unseen force was the real weapon, and in the next chapter of this story, it would redefine the meaning of modern war production. In the heart of Detroit's industrial maze, amid the rhythmic hammering of metal and the steady hum of conveyor belts, America's hidden advantage pulsed unseen. It wasn't a new engine or alloy, it was organization itself. Our system so advanced that even chaos could be predicted, and every part, every bolt, every screw knew exactly where it needed to be before a single hand touched it. This invisible force was the birth of integrated logistics. U.S. Office of Production Management, March 1943 and 1942. A group of engineers and mathematicians from MIT and the War Production Board began experimenting with something revolutionary: real-time statistical coordination of manufacturing. Using early punch-card computers and nationwide telegraph networks, they tracked raw materials from ore to airplane, predicting shortages before they happened. The system was called materials control. What Germany achieved through central command, America achieved through distributed intelligence, a web of factories that could think, adapt, and accelerate. Production Engineering Review, April 1943. At the core of this network were the manufacturers themselves, giants like Ford, Boeing, and Douglas, but also tens of thousands of smaller subcontractors. When a bearing factory in Ohio fell behind schedule, the system automatically rerouted orders to a plant in Kansas. When aluminum output spiked in Pittsburgh, it flowed instantly to where it was most needed. For the first time in history, war production wasn't just mass manufacturing. It was algorithmic warfare. Technical Manual TM 9294-1943. Germany, by contrast, still relied on handwritten reports and bureaucratic bottlenecks. Each delay rippled through the system for weeks. Albert Speer's office couldn't match the speed of America's information web, nor its redundancy. If a factory in Michigan was bombed or flooded, 3 others filled the gap within days. But when a plant in Hamburg was destroyed, its production might be gone forever. Reich Ministry of Armaments report, June 1943. And nowhere did this advantage reveal itself more dramatically than over the fields of Ploiești, Romania. On August 1, 1943, nearly 180 B-24 Liberators roared toward the oil refineries that fueled Hitler's war machine. It was codenamed Operation Tidal Wave, U.S. Army Air Force's mission record, AUG 1943. The mission was one of the most dangerous in the war. Low-level bombing through dense anti-aircraft fire, 2,400 miles round trip from bases in Libya. Every plane had to carry not just bombs, but hope. Hope that the fuel Germany burned would soon run dry. But the Germans knew they were coming. The defenses were ready. Flames and shrapnel filled the sky. Dozens of Liberators were torn apart mid-air, their wings shearing off like burning leaves. Mission debrief 1943. Yet what astonished both sides was what happened next. Within 7 days, Willow Run and its sister plants replaced nearly every lost aircraft. Ford's engineers had designed modular sections so precisely that assembly lines could swap models mid-shift. Subcontractors already had replacement wings, engines, and fuselages boxed and waiting. It was as if an invisible hand had anticipated the losses before the planes ever took off. Bureau of Aeronautics Report 1943, the German reaction bordered on disbelief. In Luftwaffe intelligence briefings, officers questioned how an enemy could lose 50 bombers one week and return the next with 200. Their production defies arithmetic, one analyst wrote. They fight as if their factories are invincible. Dramatized composite based on Luftwaffe records 1943. That illusion of invincibility was carefully engineered. America's factories were not just strong, they were networked. Companies like Motorola and Western Electric built communication lines that turned industrial America into a single nervous system. Plant managers received updates every morning, telegrams listing inventory levels, train schedules, and fuel reserves across the continent. It was war fought with data as much as with steel. Motorola Internal Memo, July 1943. To achieve this precision, thousands of unseen workers became the quiet heroes of production. Draftsmen like Margaret Hutchins, a 26-year-old engineer from Buffalo, spent nights recalculating wing stress loads using slide rules and coffee. Technicians like Joe Rivera, a Mexican-American welder at Douglas Aircraft, welded nose sections to within a millimeter tolerance. Every task was recorded, timed and improved. Even error became data. Worker Interview Archives 1944, the Germans tried to adapt. Speer ordered the creation of shadow factories, decentralized production to protect from Allied bombing. But without America's communication network, coordination collapsed. Components failed to arrive. Engines piled up with no airframes to attach to. What America achieved with telegraphs and logistics maps, Germany could not replicate under bombs and blockades. Reich Armaments Ministry 1944. The difference wasn't just industrial, it was psychological. Allied crews knew that behind every mission stood a vast machine that would never let them run dry. Fuel, parts, ammunition, all replenished like clockwork. Axis pilots, by contrast, fought with rationed fuel and dwindling replacements. "We repair what we can, but no more come," one German mechanic confessed after capture. "They have oceans. We have scraps." Dramatized composite POW interrogation 1944. Even the materials themselves told the story. Where Germany cut aluminum with shortages, America found substitutes. Synthetic rubber, molded plastics, composite woods. Chemists at DuPont and engineers at General Electric turned wartime necessity into innovation. Synthetic rubber replaced 90% of natural imports lost to Japanese conquests. Nylon found its way from stockings into parachutes. Every molecule was conscripted into service. U.S. War Chemistry Division Report 1943, and all of it moved under a single unbreakable rhythm: speed. Trains loaded with parts thundered through the night, 2,000 flat cars a day feeding Willow Run alone. The factory never slept. Men and women ate standing up, tools still in hand. Lunch breaks became repair intervals for machines. When the siren sounded, the line resumed, seamless as breath. Each hour another plane rolled forward, its engines coughing to life. War Department Industrial Film, 1944. By late 1943, the figures were staggering. Over 5,000 B-24 Liberators had already been produced. America's aircraft output surpassed Japan, Germany, and Italy combined. U.S. Army Air Force's Statistical Digest, DEC 1943. Entire squadrons were born in weeks. Combat losses that would cripple any other nation were simply numbers in a ledger. But this advantage came with cost. Production schedules drove men to exhaustion. Accidents rose. Marriages strained under endless night shifts. The war's human toll wasn't limited to the battlefield. It was felt in the clang of factory floors, in the tired eyes of machinists who hadn't seen sunlight in days. Yet still they built, because every bomber rolling out meant fewer sons dying overseas. U.S. Office of War Information, 1944. Germany could no longer keep up. Its factories bombed, its workers starved, its supply chains collapsing under pressure. Even Hitler raged in disbelief. How can they replace so much so fast? Führer Conference Minutes, Jan 1944. The answer was simple. America's true weapon wasn't its planes. It was the system that built them, and that system was only growing smarter. For the first time in military history, logistics, not generals, would decide the fate of the war. What began as a miracle of production would soon become a doctrine of dominance, one that stretched from the skies of Europe to the sands of the Pacific. The war's next chapter would reveal the ultimate power of this machine, not just to build planes, but to build momentum, a momentum that no enemy could ever stop. By early 1944, the skies above Europe no longer belonged to the Reich. They belonged to the machine America had built. Every dawn, the drone of engines rose like thunder rolling across the Channel, an unbroken procession of bombers blotting out the sun. Factories that once armed Germany now burned beneath waves of high explosives, and the Luftwaffe, outnumbered 10-1, could no longer mount serious resistance. U.S. Strategic Bombing Survey, 1946, but the real victory began months before a single bomb fell. It started in the warehouses, the shipyards, and the endless lines of freight cars stretching from the Great Lakes to the Atlantic coast. America's integrated system of production and supply had become the circulatory system of modern war. Every nut, bolt, and bullet was tracked, delivered, and consumed with the precision of a living organism. By mid-1944, the United States was producing one airplane every hour, 24 hours a day, 7 days a week. U.S. War Production Board Report, May 1944. This momentum reshaped strategy itself. Commanders like Eisenhower and Spaatz could plan massive operations knowing reinforcements would never run dry. The D-Day invasion was only possible because thousands of aircraft, transports, fighters, bombers stood ready, with thousands more waiting in crates behind them. Germany, by contrast, had reached a breaking point. With fuel reserves dwindling and aircraft losses skyrocketing, the Luftwaffe began grounding units not because of combat, but because there were no planes left to fly. Luftwaffe Losses Analysis, 1944. In the Allied command rooms, the rhythm of production dictated the rhythm of war. Schedules of factories were read alongside field orders. The number of aircraft produced determined the timing of offensives, the reach of air cover, even the survival rate of troops on the ground. The once chaotic logistics of global conflict had become a science. It was as if the American arsenal fought its own war, one British officer observed. Royal Air Force Liaison Memo, July 1944. For the German High Command, the psychological collapse was as devastating as the material one. Reports from the front describe pilots refusing to engage. Mechanics scavenging destroyed aircraft for parts. The Reich's dream of technological dominance, jets, rockets, wonder weapons, could not compete with the relentless tide of American quantity. Albert Speer later admitted, "They outproduced us because they outorganized us." Speer interrogation transcript, May 1945. Yet behind America's triumph lay countless unseen sacrifices. In the factories of California, women worked 18-hour shifts riveting wings for B-17s. In Chicago, machinists collapsed beside lathes from exhaustion. In Mobile and Seattle, shipbuilders lost fingers, lungs, and years of life. Every bomber that soared over Berlin was built on sweat, smoke, and sleepless nights. U.S. Office of War Information, 1945. The scale of production also forced an evolution in leadership. Engineers became generals of their own kind. Henry Kaiser, the shipbuilder who pioneered modular assembly for Liberty ships, proved that speed itself could be a weapon. His methods, parallel construction, interchangeable parts, non-stop shifts, spread from shipyards to aircraft plants. In California, Douglas Aircraft mirrored Kaiser's tempo, building the C-47 Skytrain, the workhorse of Allied logistics. Every 10 minutes, another transport rolled out. Douglas Production Bulletin, 1944. This system of perpetual motion transformed morale. American soldiers on the front lines carried the quiet assurance that their nation stood behind them, building faster than the enemy could destroy. Even when entire squadrons vanished, replacements were waiting. "We never felt abandoned," recalled one B-17 navigator. "Back home, someone was already building the plane we'd fly next." U.S. Army Air Force's veteran interview, 1946. For Germany, the same realization had the opposite effect. Captured soldiers spoke of hopelessness as they watched the sky darken with waves of bombers. "They do not stop," one Wehrmacht officer wrote in his diary. "It is as if their factories have no end." Dramatized composite, captured diary, 1944. The industrial disparity became a form of psychological warfare. Every bomb dropped was also a message that the Reich's power was finite, but America's was infinite. Even nature itself seemed to favor the Allies. When winter storms froze roads and ports in Europe, American engineers devised mobile heating systems to keep fuel lines flowing. When the Battle of the Bulge erupted, air resupply missions launched within hours, guided by radios built in Chicago, loaded with ammunition from St. Louis, dropped from planes built in Fort Worth. Every link in the chain held. The American war machine was not merely a production network, it was a living ecosystem. U.S. Army Quartermaster Field Report, 1945. But victory carried a final, sobering lesson. When the war ended, the same factories that had once built death returned to making life. Cars, refrigerators, washing machines. The systems designed for destruction became the backbone of post-war prosperity. What had begun as necessity evolved into a new kind of power. The power of mass coordination. U.S. Department of Commerce Reconstruction Report, 1946. For historians, this transformation marked the true turning point of the 20th century. The United States had proven that wars could be won not just on battlefields, but on blueprints and assembly lines. The future of warfare would belong to those who mastered logistics and communication, not simply tactics and firepower. U.S. Strategic Analysis Division, 37. Yet beneath the statistics and steel was something deeply human, the collective will of millions who refused to surrender to fatigue, fear, or despair. They were the silent army behind the soldiers, the ones who turned wrenches into weapons and assembly lines into lifelines. Their contribution could not be measured in numbers alone. National W.W. Museum Oral Histories, 1952. As the last bombers returned home and peace finally dawned, a single truth emerged from the smoke of war. Industrial power is not just about machines, it's about connection. Every plane that rolled out of Willow Run carried the imprint of an entire nation's unity, discipline, and determination. In that sense, America's greatest invention of World War II wasn't the B-24 or the Mustang. It was the system that made them possible. As one Allied officer reflected years later, Germany had engineers, we had America. Dramatized quote, 1951, and so, from the roar of engines to the quiet hum of peace, one lesson endures. In modern war, speed defeats armor, and connection outweighs firepower. The arsenal of democracy was not just a factory. It was the beating heart of a civilization that refused to stop building until the world was free.